All right, let's get started. When you think about cloud operations management lifecycle, what are the different phases that comes to your mind? First is infrastructure provisioning, followed by configuration management, and you always want to have some sort of monitoring solutions in place, as well as some sort of mechanisms to make sure you're staying in compliance with your governance and compliance needs. And continuously, you need to optimize your resources for better efficiency. My name is Siavash Irani. Today I'm with Sasan Hajrasuliha and Ravindra Kori. And within the next hour, we're going to show you how you can use AWS generative AI services to optimize your cloud operations for your Microsoft-based workloads. But before we start, let's take a quick look at what are the generative AI stack on AWS look like. So for people who want to build and train your own models, their own models, at the bottom of the stack, we provide different hardware, software, and platform to build and train those models. Upper in the stack is Amazon Bedrock, which basically gives you access to leading foundation models without need to build it yourself. Amazon Bedrock gives you access with a single API to leading foundation models. You can see a list of them down below from Amazon, Anthropic, Cohere, Meta, and so on. It allows you to customize your model for different use cases that you have. And also, you can automate different workflows using AI agents to automate different tasks. And of course, security and privacy and safety is built into the service. Now, if you want to, a little higher in the stack, if you want to have pre-ready applications, an AI assistant within your application, Amazon Q is there. For business users, Amazon Q Business helps you to create AI-based chat assistant based on your enterprise data. For those analytical works, you can use Amazon Q for QuickSight and query with natural language queries in QuickSight for different queries. And for developers, which we use Amazon Q Developer a lot today, you can build code, generate code, refactor your code, and security is built into Amazon Q. And also, it's compatible with majority of the popular IDEs out there. Think about JetBrains Rider, Visual Studio Code, and recently we announced support for Eclipse. There's also specialized use cases for Amazon Q for Connect and Amazon Q for supply chain. Now, with that, we get to our first phase of our cloud operations management, which is infrastructure provisioning.
Infrastructure as code. We've all heard the term. What is it? It's simply a piece of code that deploys a piece of our infrastructure for you. We all know that they come in different flavors and sizes. Some of them can be part of a compiled language. Most of them are part of a scripting language. They could be declarative. They could be procedural. They could come from the original vendor. There are many third parties and partner vendors that provide you tools and services like that to generate such codes. What they're proposing here is that if you infuse those tools and those methods that you're already familiar with Amazon generative AI services like Amazon Q and Amazon Bedrock, you're gonna get a code that is better. And by better, we mean they're easier to read, easier to maintain, easier to debug and troubleshoot and add and remove features. And they also follow best practices for, let's say, security, performance, and general maintainability of the code. We have a lot of examples for you to cover today, but before we dive into them, we thought it would not be a bad idea to give you some backgrounds from where we got all these examples. A few months back, when three of us were planning for the content for this session, we real soon figured out that we cannot work in our own individual silos, but rather we need to work on a common infrastructure so that our examples are kind of meaningful and we can make a good story off of it. So we decided to create that. Our infrastructure, it was rather straightforward when it comes to technical features out there. We had, at the heart of it, there was an instance, an EC2 instance that we called the provider instance. That was the main instance that we kept an eye on using the services that you see, AWS CloudWatch, AWS Lambda, and later on the QuickSight. And we had automation around it using systems manager features like documents and run command. And we had requester instances that, again, depending on the demo that we were trying to build, they would just simply request service from the provider instance and get the response from them. While building that, we actually set some ground rules for ourselves. We were like, OK, we're actually developing a generative AI session. Why don't we taste our own medicine? Even if something was quite trivial, like creating a VPC or so, we still went to the generative AI tool to see if asking it and using it makes a meaningful improvement for our whole process. We started with the brand new AWS account. And the reason we did that was that all of you have this experience, that when you have a dev and test environment, over time you start building some infrastructure that later on you kind of take it for granted and you forgot they're there and you just keep using it. Think about your VPCs, your VPC peering, your IAM roles. You kind of set them once and forget them, and later on in all your trial, you're just going to use them. We wanted to make sure that no corner is left untouched in this, and we don't have anything, and we kind of provision everything that we need so that we can test that with generative AI tools. AWS PowerShell as our primary CLI. We're all Microsoft guys. We love PowerShell. That's the reason we chose that. We also decided to keep our toolbox light. There are, as I said before, there are many tools that would generate infrastructure as code for you. For this practice, we just stick to what was natively available to us. CloudFormations, DSCs on the Windows. We kept it like simple and straightforward. And we also tried to do everything that we could through automation, which was almost everything. We would just switch to the console to verify that the automation or the command line that we ran did what we assumed it would do. The reason we did that was the DevOps mentality. What if we needed to do this over and over again? What if we needed to wipe out the whole thing and start fresh in another account? We needed something, a sequence of command lines, a bunch of code, something that we could put as part of a deployment pipeline and have that repeatability available to us. So this was pretty much the architecture. From the technical perspective, it was not that complicated. What was kind of interesting was at the scale that we decided to deploy this. This is the map of a subset of AWS regions. We deployed the provider in one region, but we decided to deploy the requesters in many, many, many regions around the world. 29 regions to be exact, giving us like 58 requester instances. The reason we did that, as you see in our demos later on today, we were using geolocation APIs, and we wanted to make sure that we feed those APIs real data coming from real logs so that we can have a good base to benchmark the reports we're going to get with what we knew in reality has happened out there. I mean, being AWS folks, having deployed multi-region workloads was not something new to us. But going for 29 region and that scale, even for a trivial workload like these ones, that was something new to us. And definitely we ran into some interesting scenarios and stories. So most of the examples that you see for the rest of the presentation are coming from us either building this infrastructure or using this infrastructure. With that background, let's dive into our demos. Let's warm up with something easy and easy to digest. Creating an Amazon EC2 instance using AWS Toolkit for PowerShell. What you see here is the Amazon queue for developer when you enable it on Visual Studio Code. This is your welcome screen for the prompt. It's ready for your prompt. I simply type in, generate an AWS PowerShell Toolkit script for me that creates one Windows EC2 instance in each zone I have access to. It generates the response. Let's dive deep into the elements of the response we got back from the prompt. First is an overview of what are you going to get. Then it's the main body of code with some convenience feature like copying. Then if you scroll down, you're going to get an explanation and high-level overview of what each major section of the code does for you. You keep scrolling down, you get to the part that it tells you what you need to do before running this code or after running this code to make it work, and some references to how it came up with this code that you saw. The references to public documentations and so on and so forth. And later on, some follow-up prompts that kind of seems logical to follow after this one. Speaking of good code quality, let's take a closer look at the code it generated for us. The variable names, they're all intuitive. They're coupled by the comments all across the code that will tell you either what this piece of code does in this section of the code or some to-do list. That all adds up to the readability of the code. And for example, in this one, the framework that it created for us follows the best practice for coding, which is like error handling using the try and catch phrase. These are the items that, especially if you are not a full-time developer and you do scripting as a sysadmin, you might kind of neglect to put out there. But they're good, and they will help you or your colleagues in the long run to have your code reused more often. Next example, optimizing an AWS CloudFormation template. What I have here in this example is a CloudFormation template in YAML format that simply deploys an EC2 instance. What you see here in that white rectangle in the middle is a feature of Amazon Q that's called inline code suggestion. Wherever your cursor is, depending on the context surrounding the cursor, it can come up with some code suggestions that you can either approve or reject and continue with your own coding. Another feature of that is that when you highlight a piece of code and you right-click on it, there is a context menu for Amazon Q. And when you expand that, you have different options: explain, refactor, fix, optimize, and a generic send to prompt so that you can kind of focus on that highlighted piece of the code. In my example here, my template gets a parameter for Windows AMI so that it can create an EC2 instance off of that specific AMI. I'm asking Q to help me optimize this. Let's see what it comes out with. So optimize this. This is the answer. Let's go dig deeper into the answer. The first suggestion is for me to add a description to this piece of code. That's always a good suggestion to make it more readable. Use a default value. Right now, I have to pass an AMI ID to my script, otherwise it would fail, which is a good suggestion. But let's take a closer look at the third one. Use AWS Systems Manager Parameter Store. That's right. Actually, AWS CloudFormation now supports these features that lets you query an instance of parameter store, get the values for a parameter dynamically at the runtime, and use that while it's deploying your workload. Not only that, we are supporting a publicly available instance of parameter store on which you can always get the most up-to-date AMI ID for any Windows edition or Linux edition, or pretty much any Amazon EC2 instance that we support with Amazon AMIs. This one is actually a good suggestion. I'm going to use that. The nice thing is that it already generated that enhancement for me. I would simply copy the code. When I want to paste it, as you see, the inline code suggestion kicked in. It's defaulting to a defaulting AMI ID. I'm not going to use that. I'm going to paste the code I copied from the prompt. This is for a 2019 instance. I simply updated to 2012. And now I have a CloudFormation template, which I didn't lose any feature. I can still provide custom AMI ID to it if I want to. But if I don't, I'm made sure that I'll get the latest that is available from Amazon repository.
Next in our flywheel, we get to configuration management. When talking about configuration management for Microsoft workloads, what are the different tasks that comes to mind? From credential management to server hardening to installing agents, roles, features, or simply patching Windows. Now, there are different tools out there that you may be using today, which are totally fine, right? From built-in Windows tools like PowerShell, Registry, Microsoft Management Console, group policies, or third parties that are out there. Totally fine tools to use, right? But also, AWS Systems Manager comes with different capabilities which helps with these. For example, AWS Systems Manager run command allows you to run commands on your instances at scale for both Windows and Linux instances. And Session Manager gives you interactive access to your instances through remote PowerShell. And State Manager is another tool which a part of Systems Manager, which I want to highlight within the next slide. Which with State Manager, you can basically target both your on-premises and your corporate data center instances or any other cloud provider operating systems. And it's good for when you're applying configurations at scale. Now, like any other sort of configuration management tool, you want to prevent configuration drift. And the way you do that normally is through scheduling some sort of configuration push toward your systems, which State Manager supports all those scheduling, which we see later in the example. Now, the way that these configurations are getting applied to your systems is using something called Systems Manager documents. So what are the documents are basically are the instructions that tell Systems Manager what is it that you want to apply to your systems. And now, in this case, what we are going to show you is how you can use Amazon Q to build these documents and then use Systems Manager to apply those configurations to your systems at scale. So the example that we picked was disabling older TLS protocols for your Microsoft Windows instances. As you know, TLS anything lower than 1.2 is considered insecure, and in the newer operating system, that's by default is disabled, right? So what we did, in this case, what I'm doing is I'm asking Amazon Q developer to create a State Manager document for me that disables TLS 1.2 and any lower protocol in Windows. Notice I put it by mistake on purpose. I put "and" in there. Because so if it disables TLS 1.2, then many of my systems may not work. So let's see what Amazon Q responds with. So first thing, it says, I cannot recommend disabling 1.2, but I'm going to recommend you to a State Manager document, which basically keeps the TLS 1.2 enabled, but disable anything lower than that to make sure not only your environment can still be operational, but also disables anything that is insecure. So once that happens, it gives me now State Manager documents can come in YAML format or JSON format. In this case, it's giving me a YAML format document. It gives me a description what the document does. And what I can do next is basically copy this document into a State Manager console, in this case I'm using. And then once that document is created, I can target my instances and my resources in different ways. One is using tags, which probably one of the best practices when you're applying configuration at scale. Using tags is a very efficient way to accomplish that. And the reason, what you see here, for example, I have added an application, a tag key with the value of tag key of application and the value of demo app. So what's going to happen? When I create this, what we call association, and I create this document and I use a State Manager to apply it, not only it applies to any resource that I have currently in my environment with this tag, but also it's future-proof. Anything that I build in the future with that same tag, it's going to automatically get these configurations and apply to the system. So once I do that, I can also create scheduling, based on cron schedules, or I can create a rate schedule builder, the tool, kind of through the console, and build that and then apply it to the system. Now, what is the benefit of doing this? In this example, for example, the TLS itself, when I was searching through it and figuring out how do I disable it, there's so many different registry keys, group policies for different applications, different operating systems, which you have to go and figure out in Windows, right? In this case, I didn't have to do that, right? It creates that for me, right? The second thing, because I'm using State Manager documents, I don't have to be necessarily part of domain. If my resources are part of basically domain or work group, in both cases it's going to work. Whenever the associations, basically this configuration application is going to fail or pass, I will be getting a report using State Manager, and you can do it cross-account, cross-region. Cross-account by just basically sharing these Systems Manager documents cross-accounts, or just simply copying documents to other regions for just applied cross-region. With that, we get to example 4.
So what you saw was building an SSM document from the scratch. But what if you already have a piece of code and you want to transform it into an SSM document? Let's see if generative AI can help us with that. So here, I have a piece of PowerShell code. We really don't care what it does right now. We'll come back to it on the next example. What I tell Amazon Q to do for me is to turn this script into an AWS System Manager run command. It explains to me what the process is. It generates the document. It also helps me deploy that through the command line. And I deploy it here, and now I have it. Some of you might be thinking, so it's just a copy and paste of code. What's the big deal about it? Well, the devil is in the details. Let's compare the code side by side and talk over that. You see, to make this PowerShell compatible with the SSM document format, it had to make some modification to the code. In my example, it had to pull the parameter section away from the body of the PowerShell and put it in the proper location on the SSM document. Not only that, if you look at the bottom right of your screen, it had to go into the body of the code, update all the references that used to be in the PowerShell format to the new SSM document format. And my favorite in this example, escape characters and delimiters. Literally, this was just a 15-line of PowerShell, yet we had to do that many escape characters and modification to the body of a code to make it compatible. Imagine it being hundreds of lines or thousands of lines. And by the way, I didn't even highlight all the end-of-line delimiters into this example. And the time that we saved using Amazon Q to do this test for us, that's valuable. Some of you might be thinking, well, this is JSON format. You would have used YAML. It would be easier. Trust us, we did that. Even with YAML, same things would have happened. And by the way, who doesn't enjoy fixing a broken YAML after copying and pasting a code, right? Being sarcastic, of course. Next example. This one is actually one of those that I'm happy we started with a fresh AWS account. Otherwise, we wouldn't run into this issue. The principle of least privilege. What is it? It simply tells that just give entities in your system the least amount of privilege they need to do their job and nothing more. It's one of the fundamental principles in cybersecurity. And you all being professionals in IT, you know better than me how many hack instances and infiltration instances happens because people deviate from this fundamental principle. When you want to deploy a workload, you kind of rely on the vendor of the workload to give you the list of the permissions the workload need to run properly. Again, hoping that they also abide by this rule and didn't ask for their workload to be over-permissioned. But if you don't have proper documentation on what permissions to give to your workloads, you're kind of into that whole trial and error practice now. Putting our context back to the AWS workloads, now you have to just attach and remove policies, play with the APIs, maybe have an eye on your CloudTrail logs to see who called what APIs and if it was successful or not, and then come up with your set of policies. And yet you're still not sure that whether you caught all the possible scenarios or no. Let's see if generative AI can help us with this use case. So we're back to the same PowerShell script. This time we have to know what it does to be able to move forward. If you remember from our architecture before, we had the provider and we had multiple requester instances scattered around the world. For these requesters to be able to connect to the provider, naturally their public IP addresses need to be listed on the security group of the provider instance. We purposefully configured those requester instances to have dynamically changing public IP addresses. And we didn't want to open up our requester instance to the whole internet either. So naturally, we needed some mechanism to keep this security group list of allowed IP addresses in sync with whatever is really happening around the world on these requests or instances. As it is the case for many other things on AWS, there are multiple ways of doing this. The way we decided to do it is to run a piece of code on the requester instances themselves so that whenever they have a public IP change, they can call the proper APIs and update the security group of the requester. And this is that code. It reads the metadata, adds some other information like the availability zone and all that, and then adds the new IP address into the security group. What do you need to do? What do you need to call an AWS API? You need to have permissions. How do you get your permissions on an EC2 instance? Through your instance profile. This account was new, so we didn't have any instance profiles, so we needed to create one. And that is what our prompt is. What permissions should my EC2 instance profile have before it can run this script successfully? It analyzes the code and gives me the list of the APIs that I need with explanation of what they do and why would I need them. Not only that, it actually gives me the JSON policy, which I can use. Am I going to copy and paste in the console? No. I ask it to help me deploy it through the command line, the PowerShell command line, so it generates yet another set of trust policy documents and proper command lines, and I deploy that. And as you can see, I have an instance profile that when I open the policies, I have just the permissions that I need to run that piece of script. As a matter of fact, it was too restrictive that later on when we added the cleanup version of that script to remove the stale records of that security group, we failed. And that's a good thing because we didn't have permission and we were not supposed to have permission because we didn't ask for it early on. And as you see, the proper trust relationship is there. And that helps me to use this role as an instance profile. And this is the final validation that the dropdown indeed shows that instance profile, that role available as an instance profile.
Perfect. So next phase of the cloud operations lifecycle is monitoring and performance. As you have seen, I think you might have already heard this quote, everything fails all the time, is a famous quote by our CTO, Werner Vogels, which means the software and distributed systems what you build may eventually fail because something can always go wrong. We need to be prepared. We need to build our systems so that we are prepared for something goes wrong, we are being notified. Even though the most carefully designed fault-tolerant architectures cannot prevent from all possible points of failure. We need to make sure that we have a proper monitoring and logging system so that we will be notified whenever something goes wrong. With robust monitoring in place, it helps us to detect, diagnose, and resolve issues when they occur. In Amazon, we'll be using Amazon CloudWatch, a service which is provide your monitoring services where you can see the real-time visibility of your applications and the resources which have been provisioned in the cloud. Starting with AWS CloudWatch metrics, which helps you to identify the metrics at an instance level, like CPU usage, disk read and writes, network traffic, which provides you information about the performance of your instances and take actions accordingly. Log management service, you can use Amazon CloudWatch logs, which helps you to collect, store, and analyze the logs of your instances, further extend it to your applications as well, like IaaS server logs, your SQL server logs, where it provides information about how your application is behaving, and you can use that information to debug and troubleshoot. With monitoring in place, what we wanted to show you today, the next example which I'll be demonstrating is how to visualize the Windows events. In here, I'm keeping the same architecture what Sasan explained earlier about the requester and the producer. I want you to consider a scenario wherein you are running a global scale event and you have your developers, your system administrators logging in from the different part of the globe, and you have a Windows EC2 instance running in US East region. You are in few minutes in the session, you start receiving escalations saying that many of the users are not able to connect to the machine. The traffic which you expected is more than what you expected. And at the same time, there are some issues highlighted like the username is incorrect. As a Windows administrator, the first thing I'll be doing is logging to the Windows server, go to the Windows event logs, and find out what were the error messages and what is to make sense out of those messages from the Windows event logs. In such scenario, would it not be helpful to have something like a dashboard or a solution where you can query something like this? Wherein in here, I'm just using IP addresses with request. Amazon Q, which has been supported, the Amazon QuickSight, providing you that generative AI capabilities to provide you the multiple visuals based on the data what you have pushed in. It is providing in the top left corner, if you see, a quick summary about the total number of the IP addresses, how many are unique IP addresses. At the same time, providing you the bar chart as well. And further, extending that information to identify from which particular city or the region the traffic is being initiated. I would be happy to see something like this as well, wherein I want to know from which cities the attempts been made. Wherein, so for example, in this, it is providing me a radar chart, showing us the impact from different cities, how the traffic is coming in, and at the same time providing me the region, the country, more information what you need. Or it would be another extended where I would like to see the usernames. Like as I said, like one of the error messages, if it's a username, I would like to see what are the different usernames have been used by these developers. Where it is giving us a couple of more information, it's also providing me a geospatial chart to show us the impact where the traffic is coming from. Now I would like to extend the next example which I would like to demonstrate is, like before that, I would like to just talk a quick about the architecture what we use to build the solution. First, we have Windows EC2 instances, which is helping us to push all those Windows event logs to the CloudWatch log groups. And from the CloudWatch log groups, we are pushing that data to the S3 bucket. The two reasons. One is, of course, we can keep a track of all those Windows activities that are happening for future audit trails if needed to be. And second, it's cost efficient as well, pushing the logs from CloudWatch logs to S3. Then we have a Lambda function, which is ingesting that data from the S3 bucket and then formatting it, processing that data, and making that data available in a consumable format for the QuickSight. Once the data is available in the QuickSight, the data sets are created, and then on top of that, I'm making use of generative AI service, which is Amazon Q, to query what you saw earlier. By using natural language processing, you can just provide the prompt so that any of your users, the developers, or it might be your Windows administrators can query and get the results out of it. The next example, which I would like to talk about, the analyzing the Windows events. Most of the Windows administrators, I believe, I believe you will be acknowledging this, wherein there are so many Windows instance, EC2 instance servers running, and there are error messages wherein most of the time we don't give the time or does not have the priority to look into those error messages. I believe most of the time, even these messages will be containing information about your performance issues, your configuration issues, right? Security threats, all the information are being collected. And if you think at a scale, if you have thousands of servers running, and if you want to go through each of those Windows Event Viewer logs, it's a time consuming. In such situation, would it not be helpful if your operations team receive a mail every day morning, something like this, wherein it's talking about a quick summary, which tells me about what were the error messages encountered, and what were the instances. It is grouping me those error messages. If I see a common pattern of the error messages on a different server, it is grouping me those servers and the instance ID has been provided. And at the same time, it is telling me the instances where how many times the error occurred in each of these instances. And also it is providing me the information about the prioritization. I believe even the error messages, what we saw earlier, there are some error messages may not need immediate attention, but some of them needs day zero. The moment you see those messages, you need immediate action. In such situation, the solution, what we'll be talking here, is automatically identifying those error messages and providing the information like these are the messages where you need immediate action to be taken. And at the same time, it is providing me the root cause analysis. why did this issue occur in the first place, right? And then at the same time, the event ID, like in all the Windows users, we love event IDs to find out, like what, in case if you want to refer back to Microsoft articles. And then at the same time, the mail is also having information about resolution steps, the step-by-step instructions on how can I resolve the issues which were encountered. Even this would be very helpful if you have a team, the operations team, where are not like Windows experts. This would be helpful information where they can log in and they can do the resolution for that issue which had been occurred. And also, I would like to know the original error messages which were there in the Windows VM logs. I don't want to miss that. Just for the reference, I want to make sure that the error message, what I receive from that, so that I can correlate if needed to be, or any expert can correlate and find out, okay, these were the error messages, the steps suggested by the assistant is pretty good. Now let's quickly see how we have built. The architecture remains the same. We have Windows EC2 instance, Microsoft Windows Server, pushing the logs to the CloudWatch log groups. And in here, I'm pushing it to S3 bucket, wherein in Lambda function, there are two ways I can define this or build this solution. One is I can directly query the CloudWatch log groups for the real-time data, wherein you can use the advanced querying capabilities of CloudWatch log insights, where you can query against the log groups and get real-time data based on the time range what you're providing. And once you have that data, I'm sending those error logs to the Bedrock and getting a response out of it. And once I get the response, I'm pushing that to SES so that I can beautify it and send it to our operations team. One thing which I want to highlight here is the prompt, what I'm using to send it to Bedrock. Here I'm utilizing a chain of thought prompt technique, wherein I'm telling the assistant, hey, you are a Windows administrator expert, and you're a Windows system administrator and a log analysis expert. And I'm asking it to do the initial analysis of it. I want to go through read all the error messages and categorize those error messages based on the impact on the system. At the same time, also asking the assistant to do the identification of the error messages. And then the third one would be to prioritize those error messages. Can I ignore any of these messages? Do I need to give attention in the first place? And at the same time, provide a brief description of each of the error messages. And once I have that information, I'm also asking it to do a root cause analysis. For each of the error type, what has been identified in the server, I want it to go ahead and give me the root cause analysis so that I can take some preventive measures. And at the same time, provide me the resolution steps. A step-by-step instructions, knowing us what can be taken and the administrators can perform on those servers. At the same time, like in a summary, and asking it to provide some recommendations if needed. If you see the last line of the slide, wherein the Windows error logs, the Lambda function, I'm aggregating all that information and passing it as a variable for the prompt so that all the context what you're providing is related to that error messages. These two examples, what I've shared, is mainly the capability to showcase how generative AI capabilities can be utilized, Amazon Q and the Bedrock in the operations world. Thank you.
All right. Next in our flywheel is governance and compliance. So every organization have certain standards and regulations which they need to stay in compliance with. But before going through those governance and compliance, they need to have a good inventory of their environment. So what we mean by keeping inventory of an environment, and when you think about inventory, the moment that I ask you, hey, give me the inventory of your resources, the moment you print that or you export it to an Excel spreadsheet, that's out of date, right? Because you have to have a dynamic way of keeping inventory of your environment. But what are the different inventory items, let's say for Microsoft workloads, from operating systems, their patch levels, their different softwares and applications that are installed, Windows registry, and in the case of Microsoft, licenses are super important, right? What are your SQL or Windows operating system licenses? There are different inventory tools out there. AWS Systems Manager Inventory also has a feature to capture inventory for both your Windows and Linux instances. Let's take a look at the example how AWS Systems Manager Inventory can help you inventory your environment at scale. So what you see here is I do have, on the left side, I have 3 AWS accounts, and in each account, I'm using 2 regions and running EC2 instances there. And these EC2 instances are using AWS Systems Manager inventory to capture the inventory of that region and those instances in there and send it to AWS Systems Manager Resource Data Sync. Think about Resource Data Sync like a repository of all these captured inventory captured data. Systems Manager Inventory can also work with your on-premises. So right now, I can also install AWS Systems Manager Inventory on my on-premises instances and capture all of that. Similar thing for other cloud providers. You can have Systems Manager Inventory there as well. Now, once I capture all of that, all this inventory that is now saved into Systems Manager Resource Data Sync is backed by Amazon S3. And in a JSON format, you see a bunch of files where it has what is the account, what is the instance ID, what is the different configuration. So the data is in a structured way where you can now basically query that data. Here I'm using Amazon Athena to query that inventory data, and I can then have Amazon QuickSight or other third parties to showcase, basically visualize what is in that inventory. Now, of course, what we saw is Amazon Q for QuickSight can help you query those things in QuickSight. So in this example, what I'm doing is I'm just simply asking, hey, show me the instances that have an application name Microsoft Edge and its version. And the response would be something similar to this. All the versions and the instance IDs of Microsoft Edge in my environment. Now, next is managing configuration changes, right? So to stay in compliant with your regulations needs, you need to handle configuration changes or configuration drift. And we all heard, oh, this used to work in my test environment. What happened? I didn't touch anything. What's going on, right? So, and a lot of times this configuration happens, configuration changes happen due to maybe a software update, maybe a user actually changing things, or an application gets installed. Different things, or maybe a security incident, right? So first thing you need to do to handle configuration changes is discover those, right? And then once it's discovered, you need to remediate anything that is non-compliant to set them back to its intended configuration state. And normally you do this using compliance as code. Different tools. Third parties, of course, they're fine. And AWS config is one tool which we want to highlight here. So AWS config, we talked about AWS Systems Manager, how it can capture inventory of your environment. What you see here is I'm using AWS Systems Manager inventory to capture the inventory of both my EC2 instances and on-premises. It's now in Systems Manager inventory. Now, AWS config comes with different rules. You can use the pre-built rules in AWS config or build your own custom rules for different use cases or different compliance requirements in your environment. And then those config rules can run against those inventory data that was captured using Systems Manager inventory. Later, you can view those results in AWS Config Console or get notifications, hey, something got changed. You can see a history of all the configuration of a resource. When was it compliant? When it turned into non-compliant mode? You can export all that data into S3 and basically query that later on, or with CloudWatch as well. You can integrate into that. Now, once those non-compliant items are detected, AWS config can call AWS Systems Manager Automation, where automation is another feature within Systems Manager, which allows you to run different tasks and kind of automate different tasks that could happen at AWS layer or within your operating systems. You can automate that using Systems Manager Automation. Once that AWS Systems Manager Automation is called, then I can target both resources, on-prem, cloud, or other cloud providers, and make them compliant to its intended state. Now, let's take a look at the example here. What we want to do is enforce a certain application in your operating systems, right? We all have certain requirements. Maybe you want to have antiviruses be there. You want to make sure there's certain patch level there, all that stuff, right? So in this case, what I'm doing is I'm using a pre-built rule in AWS config called required application. The rule is built into the system, but pretty much what the rule does, you just have to specify what is that app that you want to make sure it's in the system. In this case, I'm setting Amazon CloudWatch Agent as my input. I want to make sure all of my instances are being monitored using CloudWatch Agent. And next, what I do, I create the config rule. And once the config rule is created, now it takes probably, just a few minutes to run it. Once it runs, then I want to see what are my non-compliant items, right? So you look at different AWS services. Generative AI is something that we pretty much build into many different services that we build. I don't think there's any, most of the services that are out there, they have generative AI as part of it. So, and config is not an exception, right? Here in the console, what I'm doing is I'm just simply asking, okay, show me non-compliant resources for this rule, right? And what it does, next config is gonna create that, generate that SQL query for AWS config, and it's going to show me all the resources and what rule they were not compatible with. So once they are detected, now I need to fix it. Two ways to fix that, manual fix or automate remediation. In this case, what I'm doing is I'm calling a systems manager automation doc to install and configure CloudWatch Agent. By the way, that document, I used Q Developer to build the doc, and now what it does, it basically calls the document and applies the configuration. Now, next phase in our flywheel is resource optimization. You always need to, when you're doing any sort of migration, any sort of building an environment, you have to keep optimizing your environment for different things. What are those things? Cost, performance, fault tolerant, security, and in the case of Windows and Microsoft workloads, of course, licenses. Different tools, AWS Trusted Advisor, which has been around, comes with different checks with these, for these different pillars and helps you with, optimizing and gives you suggestions on those. AWS License Manager helps you with tracking your licenses and making sure, and also enforcing your licenses in your environment. And Compute Optimizer. Going back to, having AI into different services, Compute Optimizer is also not an exception. As a matter of fact, once you opt into Compute Optimizer, basically Compute Optimizer, the concept is you opt into it and it's supposed to give you suggestions on different things to optimize your resources for your EC2 instances, for your Lambda functions, for your EBS volumes, R scaling, and actually recently we released a support to optimize for your Windows licenses. So once you opt into Compute Optimizer, for a while, you're not going to get any suggestion. As a matter of fact, it takes time using artificial intelligence to learn your application behavior before it makes any suggestions. Once it learns that, then you see different suggestions like what you're seeing in the screen. On the top right, on the left side top, you see, it's telling me some of my instances are under-provisioned or over-provisioned. Recently, we actually announced support for idle instances. So if you're having instances that are idle in your environment, it can also detect that. And it gives you suggestions, hey, go ahead, downgrade, upgrade your instance type, or different suggestions to save on cost, for example, or improve performance. Now, one thing, the feature that we released for Windows, for SQL licenses, and you see on the right side bottom, that one is actually for when you have, let's say, a SQL Server, as you know, comes in different editions, right, from enterprise to standard, web, or other editions. Now, it's very important when you are using SQL Server, you're using all the features that the license provides. If you're basically using certain, not using all the features that your license provides, you're just paying for the license without using them, right? So what we do here is actually Once you opt in into SQL Server license optimization, we look at what is it that you're using within your SQL Server, and then based on that, we make suggestions. Go ahead, downgrade or upgrade to make sure you're aligned with the license type that you have on your instance. In this example, for example, what we did is I was not using all of my enterprise features, and it's telling me downgrade to standard to save on cost. To summarize what we discussed today, first under infrastructure provisioning, we showed you how you can use Amazon Q to build CloudFormation documents or use AWS Toolkit for PowerShell. Under configuration management, we showed you how Amazon Q and Systems Manager can help you build Systems Manager documents to apply configuration at scale without doing all those group policy or registry key editing. Under monitoring and performance, Ravi showed you how you can use Amazon Q for QuickSight to query your logs or send your automatically analyze your logs using Bedrock and CloudWatch. And under governance and compliance, we showed how AWS config allows you to use natural language queries to see your non-compliant items or get an inventory of your environment using Amazon Q for QuickSight and this AWS Systems Manager inventory. And under resource optimization, we covered how AWS Compute Optimizer can help you have a more efficient environment for your compute. With that, I want to thank everybody for joining our session. Please make sure to fill out the survey. We'll be out in the hallway for any Q&A. Thank you so much, everyone.